Hey, welcome back. Today we're going to be taking a look at the quotient rule. This is another derivative rule for us. But before we do that, let's have a little bit of fun for the derivatives. The first question we take a look here is, if you notice, we're given a function. F of x is x minus 2, and x squared minus 7. And this symbol notation right here, remember, they're looking for the fifth derivative. Now, I don't have to do too much for this one, because we kind of talked about this on the first day of the product rule. If I were to expand this, if I were to expand all of this, f of x would be a fourth degree polynomial. And we talked about this the other day. Well, if this is a fourth degree polynomial and we're looking for the fifth derivative, well, this becomes that derivative annihilator. You might remember we talked about that a few times. So what happens is that annihilator, this gets just annihilated. So therefore, our fifth derivative of x would just be 0. We talked about this the other day, where we said if f of x is an nth term derivative, then we said that the nth plus 1th derivative would just be 0. That's the definition of a derivative annihilator. All right, so let's take a look here really quickly. This says find the value of the first derivative, and we're given f of x is g of x times h of x, and we're told that g prime of x and g of x are both equal to 0. So we want to find that derivative, and let's see what happens here. Ready? So when we apply the product rule, we're going to get g of x, h prime of x, our product rule, the first times the derivative of the second, plus the second times the derivative of the first, g prime of x. So we're going to plug in zeros now for those derivatives that we can. We know g of x is 0, h prime of x, plus h of x, and I know that this is 0. So obviously this is just going to be 0 right there. Piece of cake. So let's take a look at our new rule for today. This is what we call the quotient rule. And this is how we take the derivative when we are dividing two functions right now. So if we have two functions, f of x and g of x. Now there's a slight caveat. G of x can't be 0, and that's just because we can't divide by 0. So the derivative is very simple. What it says is we're going to take the bottom function, multiply it by the derivative of the top, minus the top function times the derivative of the bottom, and we're going to divide that by the value of our function squared. Now, I have a hard time remembering this way, so I tend to write it this way. It's low, the bottom function, d high, the derivative of our top function, minus high, the top function, times the derivative of our bottom, d low, all over the bottom squared. Or as I like to say, low. So it's low d high minus high d low, all over low. And there's our derivative rule. So let's have some fun. Now, the quotient rule, many students don't like. It looks weird, so I'll fix that here. The quotient rule, many students don't like, but it's actually a very useful one because we just want to get an answer. We're not really interested in simplifying anything. So if I take a look here, this is my top function, so that's the high function. And this is my bottom function, or the low function. My rule says, this should be f of x, sorry about that. Our rule says if we were to take the derivative, we would take the bottom function, low, parentheses are important here, times the derivative of the top, minus the top function, times the derivative of the bottom. Well, the derivative of the bottom is just going to be 1 for us. And there's the top, low d high minus high d low. Now we just got to divide that by the bottom squared. Well, my bottom here is just x plus 4 squared. And there's your derivative. Don't simplify, just leave it alone. These do tend to clean up very nicely, but we're not into that just yet. Okay? We ain't just into that just yet here. So when we look at number 2, there's our top function, and there's our bottom. Keep deleting there. When we take the derivative, we're going to get h prime of x equals low, which is just x squared times the derivative of the top, which is cosine. Be careful, that's negative sine of x. Plus the top function, the cosine of x, times the derivative of the bottom, 2x. Dos Equis. Stay nerdy, my friends. Alright, so lastly, we just need to now divide this by the bottom function squared. Now, this bottom function squared is really x squared, but we don't like to leave it like that, so we're going to leave it as x to the fourth. And there's our final answer. You can simplify this a little bit if you want to. For example, here, I can just divide everything by x if I really felt like it. Alright, number 3. Let's take a look here. There's our top function. There's our bottom functions, that parabola, x squared plus 4x minus 7. So when we're looking for the derivative here, g prime of x, remember our rule, the low, we're just going to take whatever the low function is. That's that x squared plus 4x minus 7. Now we're going to multiply this, remember, by the derivative of the top function, low d high minus high d low, all over low low. So the derivative of the top here is, so the derivative there is just 0 for the top. Whoops, hello, keep erasing. So there we go, 0. Minus, then we take the top function, which is 1, times the derivative of the bottom, which is 2x plus 4. And then we're going to divide that by the bottom squared. Now later on, we're going to be doing this one much faster. Squared. You can leave your answer like this if you want, or you can simplify it and just make it negative 2x minus 4 over x squared plus 4x minus 7 squared. And that would be your derivative there. Either one's acceptable. Alright, let's talk about tangent of x. Tangent of x, we don't know its derivative yet, but we can figure it out by writing in its expanded form. Tangent, remember, is just sine of x over cosine of x. So if I want to find the derivative of tangent, I would use my quotient rule that we just learned today. So our quotient rule says, take the bottom function, cosine of x, multiply that by the derivative of my top. Well, what's the derivative of sine? Oh yeah, that's cosine. That's cosine of x minus the top function times the derivative of the bottom. Well, the derivative of the bottom is negative sine of x. And then we would just divide that by the bottom function squared. Now, we can leave it like this, or we can do a little bit of algebra here. You might remember last year that if this becomes on top just cosine squared of x. Plus the two negatives here become plus sine squared of x over cosine squared of x. So from last year in pre-cal, you should remember that the top here is just going to equal 1. So this becomes 1 over cosine squared of x, which is just the secant squared of x. So therefore, we can actually say that the derivative of tangent of x is secant squared of x. And yeah, you're going to have to remember that one. Later on, we're going to talk about the derivatives of all the other trig functions too, cotangent, secant, and cosecant. So in the meantime here, let's take a look here. Number 5. Number 5, it is saying we want to find this derivative. Now notice there's a lot of splats by here because this one is kind of a big one for us. Again, on the top, I don't like that x, the cube root of x. I'm going to write that as x to the 1/3 over x squared plus 3. When we take this derivative, we're going to take the bottom function, which is this x squared plus 3, multiply it by the derivative of the top, which becomes 1/3 x to the negative 2/3, minus the top function, x to the 1/3, times the derivative of the bottom, all over the bottom squared. Now you want to be really careful with this one because there's one thing that we do not like, and this negative exponent right here. So we have to get rid of that of our complex fraction. This is called a complex fraction, because it's a fraction over a fraction. And when we do this, something really cool happens. The bottom is simple. We're going to get to 3. We got the x to the 2/3 times this x squared plus 3. But on top, let's see what happens when I distribute. Over here, notice the 3x to the 2/3 is going to cancel, and that's just going to leave us with x squared plus 3 minus, but now I have to distribute to here as well. And if you distribute to the first term, there's nothing to cancel on bottom, but I can multiply the 3 and the 2 together, and that's going to give me 6x, and I'm going to add these two powers together. And I do realize I did kind of make a mistake here. I want to point out to this real quick. This wasn't a 1/2 here. Some of you had probably caught on to that. That should be a 1/3, which does affect our little answer right here, because what's going to happen here is when I add them, this actually gives me now 4/3. So I'm sorry about that. That does affect our answer a little bit, because now when I multiply them, I can add these exponents together. 4/3 plus 2/3 is 6/3, or just 6x squared there. And there is our final derivative. This one's a little bit tough. You may want to try this one again. 5 is a very tough derivative to take. All right. So go into my next video. We'll take a look at some more problems. See you soon.